Hello, fam. I hope you're well. I hope you're good. If you're not, as I always say, take one day at a time. Alright? So, guys, one thing, don't forget to give God all the praise and all the glory all the time, Buffets, alright? So today I would like us to focus on what we call complex numbers. Complex numbers. Numbers can be a bit complex sometimes, right? They can be a bit, even numbers can behave like people. They can actually be complex. They can be a bit complicated. As there are people, okay, as basically as people were complicated at some point, so does the numbers, you know. You guys are used to like real numbers, like they're easy numbers because there's natural numbers, whole numbers, integers, rational, irrational, da 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 da. You get it? So these are basically complex numbers, and I'm going to cover up some few basics about the complex numbers so that you guys can actually understand, right? Before I go any further into more details and stuff, I hope you all know my name, right? I'm James, the decomposer and the synthesizer of math and science. What? Tutor. You got it. You got it. You got it. You got it. Okay. So guys, what are complex numbers basically? Complex numbers, guys, are combinations of real numbers and imaginary numbers denoted by, that is, z equals to a plus IEB. That's the definition of what? Complex numbers. Someone can say that complex numbers are numbers composed of real and imaginary numbers. Huh? Complex numbers are numbers composed of real and imaginary numbers, denoted or represented by what? Z equals to A plus IEB. Now, where A stands for the real numbers and the IEB stands for the what? Imaginary numbers. Imaginary. So A, when you see this A, right? The A in this, like this type of a form, guys, this type of an expression, guys, this type of an expression that you see, it's an expression that represents complex numbers. So I'm saying to you that whenever you see A alone, it's a real number. It could be any whole number, natural number, integer. Those are real numbers, all right? IEB stands for imaginary numbers, basically. Numbers that are not real, imaginary. When you are just imagining something that is not real, you're just having a picture of something that is in your mind and it's not literally existing. You know what I'm saying? That's basically what imaginary numbers are. So I'm gonna give an explanation again in terms of what are real numbers and what are imaginary numbers, because right now we know what complex numbers are. We are saying that complex numbers are made or composed of real numbers and what? And imaginary numbers. Okay? So, what are basically real numbers? Real numbers are numbers that do exist. Alright? Real numbers basically are made of whole numbers, natural numbers, integers, rational numbers, irrational numbers. Those are what we call what? Real number systems. But when you talk about imaginary numbers, we're basically talking about numbers that do not exist. No more right, you guys. You get what I'm saying? So I just want to show you guys something so that you guys can really understand. Check this out. Check. So we are having something like this. It's a bigger circle, and then you have a smaller circle and another circle. So this smaller circle is known as complex. These are complex numbers, and the smaller one, and this one is known as real numbers, and this one is known as imaginary. Okay. So Complex numbers is a system of numbers made of real numbers and imaginary numbers. Okay. Basically, you guys, you're familiar with this type of mind map. You know, when you look at the mind map of real number system, it's like um rational, irrational, you know, integers, what, you know, if you can check those basics from lower grades and stuff. Yeah. So this is basically what complex numbers are made of, right? So check the real numbers, guys. If I have square root of 4, it's gonna give me 2. If I have or someone can say square root of 4 gives me, it will give me 2 or negative 2, basically, because if I have, I'm gonna show you something. Let's just keep this one in mind. Square root of 1, square root of 100, square root of 16, square root of 25. It's gonna give me 5, 10, 1, 4. So these are real numbers. No, you know, when you, the reason why you are seeing these numbers, they just give you like an exact number, a natural number, a whole number, is because of these numbers are perfect squares. They are what? Perfect squares. And perfect squares, in most cases, they tend to be what? Rational. Imperfect squares, they give you what? Irrational numbers. For example, if you see square root of 7, square root of 2, square root of 3, they will give you like 1,333 or 1,4 something. Those are irrational numbers. Irrational numbers are numbers that are non-terminating and non-recurring. Are we together? Let's talk about this for the last time. Irrational numbers are numbers that are what? Non-recurring and what? Non-terminating. What is to terminate? To terminate is to stop, is to end. So if something doesn't stop, doesn't end, it's gonna what? It's just gonna keep on what? Continuing to infinity. That's what we mean. Irrational. The term irrational. Irrational simply means that numbers are what? Non-terminating, recurring. What is to recur? To recur is to repeat itself. So these numbers tends to not to repeat themselves. For example, if you have like, it gives you like 1,438,6 blah 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 blah. There is no repetition of numbers there. So this one is an what? Irrational number. But if you focus on 1/3, it's gonna give you like 0,3333333. There is a repetition of a number there. It's a what? It's a recurring number. A what? A recurring number. This number recurs. It's recurring. It's basically what? It's repeating itself. 0,33333. It's a rational number, because rational numbers are what? Numbers that are terminating and recurring. Did you hear the opposite? Did you hear the difference? I hope you did. Okay, so for example, I can also look at half. Half will give me 0,5. What happened there? Is there any repetition there? No. Did the numbers continue to go on? No. But did what? It stopped. So this number terminated. So the numbers that can terminate, that can stop without continuing any further, or that can repeat themselves, they tend to be what? Rational numbers. So a combination of rational numbers, irrational, they are part of what you call real number system. Together with the integers like minus 1 up to negative infinity, including the 0, and to positive infinity, from 1 until positive infinity. Those are real number system. Imaginary numbers. Let me show you what are imaginary numbers. Imaginary, something that is guys, have you ever seen yourself like you just had a dream, or like something that is not really existing, but it's just you yourself, you're seeing it, but it's just not there. It's just, you can only have a picture of it, but it doesn't exist. It's like, you're looking at yourself driving this Mercedes or this BMW, or you know, but then it's not really there. That's just it is just you imagining, you know. So they are basically numbers that are like kind of like that as well, guys. You know what I'm saying? So guys, check this out. want you guys to understand what I'm talking about. Check this out. So look, square root of -1. Press your calculator right now, guys. Like, press your calculator right now. Square root of -1 and tell me what is the answer. Square root of -4. Square root of -100. Square root of -25. Square root of -36. You know what's going to happen? The calculator will tell you maths error, or math error. It's going to write something like this. Math error or math error. Meaning that it's unknown. Basically, when the calculator says math error, what it says is it means it's unknown. We do not know. Not that it's impossible, not that it's uncertain. Guys, let me teach you something. It doesn't mean that we cannot have an answer of this. No, we can. It's just that it's not known. I just want you guys to understand. Someone will be like, no, it's impossible to can have the answer. Guys, no. Don't say that because you haven't tried it. It always seems impossible until it's what? It's done. Keep this in mind. Live by this. It is always seems impossible until it's done. So the moment you do it, you'll be like, no, man. I always thought this was impossible, but now because I've tried it, it's possible. That's why the term or the word impossible simply means what? Impossible. I'm just saying, guys. Let's continue. Okay, so the calculator will be telling you that is a math error, but what does it say? It means that it's unknown. All right, it's unknown. That's why in math we basically say that it's undefined. The value of the square root of -4 is we cannot define that because we do not know. Not that it does. It's not that not necessarily that it's impossible to can be done. No, it can be possible. It's just that we do not know yet. Okay. That's why now we're getting to the point of what? Complex numbers. Complex numbers are basically the ones that are helping us to... That's why I ended up saying the goal. The goal of complex numbers is that they are helpful in terms of finding the square root of negative numbers and other things. So I just don't want to get deeper because of university, they're dealing with complex numbers as well. I just don't want to get deep. I just want to give you like small basics. You know what I'm saying? For those that are doing advanced math and, yeah. So, okay, fine. Let's continue, guys. Let's continue now. I hope I was able to give you the difference between real and non-real. But I'm going to show you something. Sir, it's impossible. Decompose. Square root of -1. You know it, you. Okay, guys, check this out. Just check this out. So, I want you guys to know there is something known as iota. Iota is known as I equals to the square root of -1. So that's where complex numbers comes in. So complex numbers says that if we have a square root of a negative number, we must know that at the end of the day we are going to end up giving what? Complex number, meaning we're going to end up giving the z equals to a plus ieb. Okay, so the I that you see here, guys, this I that you see here, it stands for this name, iota. Okay, which is this I here. So I equals to the square root of -1. So remember in maths, if you have x squared equals to 4, what do you do if you want x? We're going to take what? Square root both sides. Remember the law of math says that whatever that you do on the left must also be done on the right. Are we together? Whatever that you do on the left must also be done on the right. So what I'm going to do is that I'm going to say the square root of x squared equals to plus or minus square root of what? Of 4. Meaning that my x is going, my values are going to be what? X equals to -2 or x equals to 2. Guys, remember when you're taking a square root of any number, it's always a plus or a minus. Why? Can I show you something? Check. X squared. Remember, take this one to to the other side. Remember, anything that crosses the equal sign is gonna change its sign. Let's keep that in mind. So when you're positive and you're crossing this river here, which is the equal sign, you're going to become negative if you're positive. If you're negative, you're going to become what? Positive. So even in life, guys, I want you guys to understand and to know that there is no way you'll ever remain the same. If your life is negative at the moment, just know that your life can change and become positive. And if you think that you are having pride because of your life is positive, let me just tell you, your life can just simply change out of a sudden. It turns out to be negative. But I pray that may you not be negative, that may you remain being a positive number. That's why on a Cartesian plane that you can see that we have positive numbers and negative numbers. Then there is 0 at the origin. That 0 at the origin represents our God. Anything that passes through the 0 changes. That's why God is the transformer. He can transform you. Oh, okay, let me not go deep into that. But I'm better at one maths. Then check, we're going to have minus 4 equals to what? To 0. Then check. When it's like this, I can do what? Factorization of what? Difference of 2 squares. So I'm going to have x minus 2 into x plus 2 equals to 0. Then we know the law of math says that if a times b equals to 0, then a equals to 0 or b equals to 0. So check this out. This is my a, this is my b. So I'm going to say x minus 2 equals to 0 or x plus 2 equals to 0. Then I know x equals to 2 or x equals to negative 2. So I just wanted to prove it to you guys that this is how I got this answer of minus 2 and plus 2. You get it, guys? So even factorization was able to can back up, to can actually help us basically that, you know what, even if you can do it with that method of doing square root both sides, we can also help you out with another method of factorization of the difference of 2 squares. You can check my video of factorization whereby I was covering the basics of factorization. Check it out, guys, check it out. Yeah. All right, let's continue quickly. So now, I hope you're able to see something, right? This is the goal, why? Now, when it's like this, if I want to remove the square root of negative 1, what do? I square it. So I'm going to, it's I, negative 1, I square it. So what happens is going to be I squared equals to what? Negative 1. Then this is the goal. This is where I wanted to arrive. Guys, keep these two things in mind. So the iota, guys, that you see, which is this buffet 2, equals the square root of negative 1. So meaning that we can change any imaginary number into something beautiful. Whatever that seems impossible into your life, God can just make it possible. That's why when you press square root of negative 4 on your calculator, it says math error, it says undefined, because you're on this planet, you're on earth. It's impossible, it's uncertain, but trust in the Almighty God and pray through Christ Jesus. Let me tell you something, it's going to change. Check this out. You know what's going to happen? This is how God can just transform your life. And then be like, who's this person? They start to be like, no man, you're complicated, can't you know? They don't understand how your God works in your life. You know what I'm saying? Check this out. This is the same as square root of negative 1 times 4. Alright? So I'm going to apply the law of sets. Check this out, guys. Remember, you still remember these rules, ne? Check. I'm going to apply the law, the laws of sets. It says that square root of A times B is the same as square root of A times square root of B. Square root of A over square root of B is the same as square root of A over B. This is from the laws of sets. So if we have two numbers that are being multiplied together in the same square root, we can separate those numbers, but with a multiplication. No addition, no subtraction, no division, but multiplication. That is the law. That is the first law of sets. Okay. or one of the laws of sets. Number 2 is the one of the division of the sets. Square root of A divided by square root of B is the same as the square root of the square root of everything, like A over B. That is that. Okay, so this is what I'm going to apply here. Then I'm going to say square root of -1 times square root of 4. What did I say? I said to you that, guys, I equals the square root of -1. Didn't I tell you that? Let's talk. This is how God can transform your life into, like in a second. That's what the grace of God can do. The mercy of God. Now, check this out. This one is going to be what? My I. Because it's iota. And remember that I squared equals to -1. When you take the square root of this, it's going to give you this. So check. Where I see square root of -1, and now it becomes what? I. Okay, these are the basics of complex numbers. Then what? Times, what is the square root of 4? It's 2. Check on your calculator. It's going to give you what? 2. Then what's going to be the answer? 2i. So meaning that square root of -4 equals to this. Is it still impossible now? No. This is what, and look, it looks different. If you check, square root of 4 is exactly 2. Square root of -4 is 2, is positive 2, but with an I. Now it shows that you're no longer like, that's what the Bible says, that do not be transformed by the pattern of the world, but be transformed by the renewal of your mind. Excuse me. So it shows that when you have God in your life, when you have Christ, when you've accepted Jesus Christ as your Lord and your Savior, what happens is that you're going to be different from the rest. I'm just saying to you guys, okay? You know yourself that you're different from the rest of the people. Basically, you might be a complex number, or you might be a real number, all right? Because this is an imaginary number. It's a real number. So guys, what really happened here was that we were able to change something that seemed impossible to be possible in a way. Okay, so this is the basic things that you guys need to know under complex numbers. Well, I have not yet done. Something more is coming. Check it out. Okay, let me see if I can. Oh, some people can be like x squared -1 equals to 0. X squared plus 1 equals to 0. Guys, please tell me which one is gonna be a real number equation, and which one is gonna represent a non-real or an imaginary equation. Yeah, which one of the equations here it falls under the real equations or real number system or imaginary? Check this one. I can say x minus 1 into x plus 1 equals to 0, which is going to be x minus 1 equals to 0, or x plus 1 equals to 0 using the laws of factorization, and then x equals to 1 or x equals to -1. Do you see what I've done there, guys? That is the rules of factorization. This is the difference of two squares. Difference of two squares. Because 1 is a perfect square. The square root of 1 is just 1. Square root of x squared is x. So those are perfect squares. Okay. We come to this one. It's not the difference of two squares. This is an addition. So if I say x plus 1 and x plus 1, and I think it's going to take me back, it's wrong. Guys, let me teach you something. Simplify. I need you guys know how to simplify algebraic expressions. Simplify this binomial by this binomial. Make sure that term A multiplies term B. If it takes you back, you are good. If it doesn't take you back, it's wrong. Okay, so this one will never take me back, because this one, when I simplify, is going to give me x squared plus 2x plus 1. So it's wrong. I need to have 1 and x squared. Where is 2x coming from? So it shows that this one was wrong. Okay, so if you put minus and you think you're correct, and this is wrong. We know what is negative times positive. It's supposed to be giving us negative, and we need positive. Okay, so meaning that this one cannot be done. So that's why it tends to be invalid. That's why in maths we end up saying that this type of an equation is invalid. We can't solve for x like this. So this tends to be real. It's for real, and this one is for imaginary. Because the answer here is going to be x squared will be equal to -1, and you can't find the square root of -1. Remember? I'm just saying this one is going to be x squared equals to 1. So this one and this one, they are very much different. As you can see, guys, as you can see. All right. So from here you can see that there is a difference between real and imaginary. Okay, just to break it down further for you guys. All right, guys, please don't forget, if you have any suggestions, any questions, anything, guys, on the comment section below, bafethu, please share bafethu, okay? And don't forget to subscribe, don't forget to like, don't forget to share these videos, bafethu. All right, bafethu, and the goal is to go and we reach 500 sub bafethu. Right, we need those subs bafethu to be 500 bafethu. Let's support each other. Let's go bafethu. Let's do this bafethu. Langizwa bafethu. Bafethu, ngiyalicela bafethu, ngiyalicela bakithi. Hayibo, ibani nomusa. Hayibo. Okay, let's continue and deal with these complex numbers. All right, check it out. I know some people are like, man, you haven't done anything yet. Still coming. Okay, let me see. I need some questions. Okay, guys, like for example, if you see 2 plus 3i, or you see 5 plus the square root of what? -15. Is this the only one? Yeah, this one. Remember I said to you that z equals to a plus ieb. Any form, any expression that looks like this, bafethu, any expression that looks like this, we call it a complex system, or I can say it's a complex expression. Okay, because the a is this one. This is my a, my I, as you can see. All right, this is how we put it. This is how basically some people can just say 2 plus i3, but basically it doesn't really look nice. A number must always comes before a letter, you know, when you are dealing with algebra and stuff. So that's the reason why. Okay, so that's your a, and that's our b, that's our I. Okay, so okay, fine. The goal here is to show you that 2 is there. If they ask you between on this expression, which one is a real number? A real number is 2. This part here is a what? Imaginary number. Then we come to this part. Which one is it a real number? 5 is a real number. Come on. Oh, sorry, it's a real number. This one. Guys, do we have a square root of -15? Let's start right there. I was just giving examples, like, so obviously we know that it's a no. So it's going to be what? Imaginary number. So we can't take this one. So these are the kind of examples to can show you guys about complex numbers, basically the expression of complex numbers. All right, so that you guys can be able to identify the difference between a real number on the expression and the imaginary number, and an imaginary number on the expression. So that's the difference. Come on, guys, you have questions, you know what to do with it. Don't be afraid. Okay, don't even hesitate. All right. Okay, go and good. Right, now let me just draw a table for people to understand. I want people to understand, to really understand. And then I can make something like this here, and then here I do this, right? And then I can just say here they are complex. Here I want you to give me the real numbers. Here I want you to give me the imaginary. You must imagine here. Tell me what is real. Tell me what you are imagining, Buffett. What, tell me your imagination of it. Okay, so the first one is going to be minus 1 plus 2i. Number 2, 7 minus 9i. And then minus 6i. And then 6. Okay, guys, tell me. You need to identify here what is the real number, because I just showed you some examples. These are the basic introduction for people to understand complex numbers. If you're not familiar with this topic, you're not familiar with this word, this term, complex numbers, this is where we start, Buffett. Okay, let's start right there. I said A stands for the what? Real numbers, imaginary. So negative 1 is an integer. So meaning that I'm going to say negative 1 is a real number. What about an imaginary number? This one's going to be 2. Very good. That's how you break them down. This is how we decompose. Are we together? And we synthesize new complex numbers for you. Okay. So now, again, A is a real number, Buffett. It's 7, Buffett. Oh, come on. Ola 7. CR7. Zola 7. CR7. I mean, that's what I wanted to say. Then it's going to be 7 and minus 9A. Now, 9I, as you can see there. So that's your imaginary number. And then here is we only have minus 6i. So do you see a real number? Yes, there is a real number there, but someone can't see it. What is the real number that you can see there? It's 0. Guys, basically this is 0 minus 6i. The answer is still going to be what? 6i. So I'm going to put 0 minus 6i. There you go, guys. There you go. Now you're getting it. We see. So guys, basically this is how you identify real numbers and imaginary numbers from complex numbers. Okay, from the complex number expressions. So here we have 6. What about our imaginary? 6. So meaning I have 6 minus, okay, I can just say plus 0i. So meaning I'm going to put 0i. Because this one will give me what? 6. That's the difference, guys. I guess this table was able to can help you guys to can be having full understanding in terms of what is a real number, what is an imaginary number from a complex number. Okay, guys? Good. Now, let me give you some good stuff now. Remember, we just got started, Buffett. We just got started. Okay, let me see right now. What can I do? Here are the rules before I go into much details. Yeah. Here are the rules. Let's start with the addition rule. We have addition rules of complex numbers. So let's talk about addition. This is an addition rule of yeah. So we have A plus plus C plus IE D. Okay. So it's gonna be equals to what? A plus C plus IEB plus IED. And then from there, this is the same as A plus C plus, I can take out the common factor as my I common factor into B plus D. That is the formula. That is the formula of the addition of complex numbers, guys. Just make sure that you write that down, Buffett, okay? Yep. And if you're having any questions of complex numbers that deals with addition, this is your time to can pause a video, use this method, and just get started. And if you feel like you're struggling with it, put it there and I will decompose it and synthesize it for you. Okay, awesome. Now let's look at another method under subtraction. So basically it's just gonna be like same thing, but we just yeah. So now equals to A plus C. So basically what we do is that we group the real numbers together and the imaginary numbers together. Okay, Don't complicate things. You see, we like to complicate things in life. Do you get what I'm saying? So, excuse me. You see that this thing cannot dissolve. Put it there. This one can dissolve. The things that can dissolve, you put them on the same side. The ones that cannot dissolve, you put them on the other side. Are we together? That's what I'm going to do here. Minus Ci plus. Then for me, we're gonna have A plus C minus the I is our common factor into C plus what? Plus D. That's the goal. Wait, no. Did I do this one correct? No. No. It's not supposed to be like this. I don't know. Why? What have I done here? It's B. It's supposed to be B. Hi. I'm sorry, guys. I'm sorry. My apologies. Check this out. It's A, I, B. Okay. So since it's like this and we are grouping the, remember the first term is subtracting this one. So I'm supposed to say minus C. And then here I'm supposed to say IEB subtract this one, because meaning this one minus that one. So I'm sorry for that, okay? Now I guess it makes sense to you guys. Minus C, and then it's gonna be B minus the D. Yeah, sorry guys for that. My bad. Yeah, so this is the formula of complex numbers. This is for subtraction. Woo. But one matter about better decomposer. What were you doing there? Okay, so it's subtraction. Yeah. So this is the method of complex numbers when we'll be subtracting or taking away. Okay. So that's what we do. Guys. This is just the formula. Okay. Now, what about multiplication and division? Then I'm gonna close with this method. Then I have multiplication. With multiplication, I can have that I plus IB times C plus ID. Then here, I'm gonna have AC minus BD, right, plus I into AD plus BC. This is the formula, guys. Okay, this is the formula, guys, for when you're dealing with multiplication of complex numbers. Okay, so the first bracket and the second bracket. So what happens is that the A will be multiplied by C, you subtract it by B multiplied by D, then from there plus the I, which is your iota, and then now it's vice versa. So they exchange partners, A times D, C and B. So because we're dealing with subtraction, now we're going to be dealing with the addition. All right. That's another method. I'm going to cover the multiplication and division part on the next video. For now, I can help you guys with the subtraction and addition, okay, and other things. All right. And please, guys, talk to me. If you feel like maybe I'm kind of like fast, like a speed of light, slow me down a bit, eh? I'll move by the speed of any material. Okay, the division is gonna be A plus ID, supposed to be B, right? And then this is divide by C into C plus ID. So the answer is going to be what here? It's going to be AC plus BD over c squared plus c squared plus d squared, close the bracket, plus I into BC minus AD over c squared plus what? D squared. So this is the formula, guys, for the division. This is for division. So when you're dividing complex expressions, complex numbers, this is what the formula that you must apply. As long as you know this is A, your IEB, your C, your IED, this is what you must apply, guys. But I'm going to be showing you on the next video on how to apply division and multiplication. Okay, guys? Yeah. All right. Then now, what's left? Okay, now I think we can do these ones, guys. Please, quickly, guys, do this one. Minus 49, number 2. Square root of negative 9, number 3. Square root of negative 24. Yeah. Guys, please, what is the answer for me? Come on, guys, look. I gave you a chance to can go through some basics that I've covered so far. Then now I want us to go back on those basics that I was giving you so that you guys can try these ones out and see if you can really understand this. And if you can't understand or you're struggling, then you need to come back to the decomposer so that you can be decomposing your brain and so that we can form new ways, all right? So you can understand. All right, guys, talk to me. I'm waiting. Just pause, and then do the video. And do the problem. But I got you, don't worry. So this is what you do. Remember, guys, the goal. I equals the square root of negative 1. So meaning here, I'm going to say square root of negative 1 times 49. This is the same as what? You apply the laws of sets, remember? Check the video from the beginning there, you'll see. Then I'm going to have square root of negative 1 times square root of what? 49. Square root of negative 1 is the same as my I. So I times, what is the square root of 49, guys? 7 times 7 is 49. Square root of 49 is 7 because that's a perfect square. So I'm going to have 7. At the end of the day, I times 7 is going to give me what? 7i. That's the answer of it too. If you saw yourself getting this answer of it, to give yourself a round of applause and tell yourself that I am the best. But remember, I can do all things through Christ Jesus who gives me the strength. So on your own, guys, you can't make it. So it's all because of God. So give him the glory, okay? All right, awesome. Now let's come back, guys, to check this too. This one, same method. Square root of negative 1 times square root of negative 1 times 9. Then now we apply the laws of sets. Square root of 1 times square root of 9. Then this one is going to give me what? I, because we remember, I equals to square root of negative 1. I squared equals to negative 1. Sorry for that. I don't know why I may keep on here. Then times what? Times 3. Remember, guys, 3 times 3 is 3 squared, which is 9. And square root of 9 will take you back. Okay, it's a perfect square. So the answer is going to be what? 3i. 3 iota. So that is the answer, guys, for the square root of negative 9. I hope you guys now can be able to simplify this ones. Ne? Easy peasy. Okay. Let's do this one now. this one, square root of negative 1 times 24, square root of negative 1 times square root of 24. This is I. Then what about this one? Square root of 24 on your calculator is going to give you, wait, I think you're going to get this on your calculator. Guys. You're going to get 2 root 6. So basically, if you want to simplify sets, focus on perfect squares. Basically, you focus on the factors that will give you 24, and one of the factors that gives you 24 is a perfect square. So like 4 times 6, another one is 12 times 2, but 2, is it a perfect square? No. Is it a perfect square? No, because square root of 12, it won't give you like an exact number. Same applies, you see. But here, we know that square root of 4 will give me an exact number, which is 2. And then this one cannot be simplified. It will remain as it is. So that's how you actually simplify sets. If you're struggling with how to simplify sets, guys, just let me know. And I'll make sure that I make that video for you guys of how to work on sets, okay? Then now it means I'm going to say times square root of 4 times 6. Can I write it up there so that you guys can be able to see? Alright, so this is basically I, equals to I times square root of 4 times 6, which is the same as I times square root of 4 times square root of 6, I times 2 times square root of 6. Then the answer of the day is what? It's going to be what? 2I square root of 6. Oh, someone can just simply say that, someone can say it's 2 root 6I. Don't put it like this. No. Don't do that, guys. Because this I is not in the root. It's separate from 6, so don't do that. Don't do that mistake, okay? So you can either leave it like this or like this, alright? So basically like this, which is the same as that one. So yeah, that's how you simplify the sets of complex numbers, or that's how you actually simplify complex numbers. You see, they're challenging a bit if you're not having the basics and stuff, okay? But this is one of the reasons why we are here, guys, to help you. And okay, I'm also willing to learn a lot from you guys. If you're having anything, don't be afraid to can share something, okay, guys? All right, and then let me see if I can okay, for example, you guys can try this one as a homework. 3, okay, let me just do this one for you. 3 plus square root of negative 9. This one, remember, it's going to be 3 plus square root of negative 1 times 9. And 3 plus square root of negative 1 times square root of 9. Then 3 plus, this one's going to be what? I times square root of 9 is 3. Then the answer is going to be 3 plus 3I. Guys, what did I say? A is a real number, imaginary number, because we said Z equals to what, guys? Equals to A plus IEB. That's the goal. That's the goal of A2. Do you see it right now? So that is how, guys, we decompose complex numbers, guys, so that you guys can understand, okay? Now, let's do last problems, guys, for you. But before I do last problems, there's a word for you guys, like 2, negative 18. Go and try these problems, guys. Go and try these problems. Square root of negative 12 plus square root of negative 27. Come on, guys. Come on, guys. Come on, guys. This is your work. I need you guys to challenge yourself with these questions. And the last one could be square root of 9 times square root of what? Negative 4. This one is also easy, guys. Remember guys, square root of negative 1 times 9 times square root of negative 1 times 4. This is for this one, okay? Then you're gonna say negative 1 times square root of 9 times square root of negative 1 times square root of 4. Then this one is your I times your 3 times your I times your what? Your 2. Okay? I can erase this problem because you guys can see them, right? Remember 1, 2, 3. I want you guys to challenge yourself with them. If you're struggling, come back to me. All right? On the comment section there, guys. Bona. Let me know. So check, guys. Then we're gonna have what? We're gonna have I times I, and then we're gonna have 3 times 2. Okay? Then what's gonna happen here, guys, is that I will give us I squared, and then 3 times 2 is basically what? 6. So remember, guys, I equals to square root of negative 1. I squared equals to minus 1. So I squared is the negative 1 times 6. The answer is going to give us negative 6. That's how we do it. I squared is this one. Remember I told you guys, these are the basics that you're going to need. I times I is I squared. Then I squared is negative 1, you know. So wherever I see I squared, I put negative 1. Negative 1 times 6, negative 6. So meaning that square root of negative 9 times square root of negative 4 equals to what? Negative 6. God will do the impossible to be possible. I'm just saying to you guys that you must believe. Don't never doubt yourself. Alright. Okay, guys, let me do this 3 problems and then we are all sorted for addition and subtraction, okay? Okay, let me have this one. It says 3 plus 5i plus into 2 minus 3i. Remember the goal, guys? You combine the real numbers together and the imaginary together. So it's going to be what? 3 plus 2, okay? Plus what? Plus 5i plus into minus 3i. Yeah, you can just do it like that. Then from there, 3 plus 2 is going to give us what? 5 plus. Take out the I as a common factor. Okay, positive times negative is negative. So I'm going to have 5i minus 3i. Okay. Then from there, I'm going to have 5 plus. Then I outside of the bracket. Then I have my 5 minus 3. And then at the end of the day, I'm going to have 5 plus. What is 5 minus 3? 2. So I'm going to have 2. Okay, it's fine. People want to see step by step. I into 2. Then from there, what do you do, guys? So I times 2 is the same as what? 2i. So don't be surprised when I'm going to change that answer of mine and write it as 2i. This is what you call a complex number. As I've said, guys, complex numbers are in the form of a plus IEB. As I've said, imaginary number, real number. Are we together? Okay. Let's do the last 2. Okay, quickly. And then if we have number 1, 7i minus into 4 plus 5i. How do we do this one, Mr. James, the decomposer? Check it out. It's 7i. Negative times positive is negative. Negative times positive is negative. You combine the like terms together. They're imaginary on the same side. So I'm going to have 7i minus 5i minus 4. Okay. So basically, the I will come out 7 minus 5 minus 4 will give us how much? 2, right? Because you have 5 6, 7. So to get to 7, you must add 2. So meaning we have 2 minus 4. Then check it out, guys. I into 2 will give us what? 2i. That's how we get the answer. So now I'm going to write it the way it's supposed to be written. So it's going to give us what? It's going to give us 2i minus 4. Okay. But is it how it's supposed to be, the standard form? No. Remember, z equals to a plus ieb. The goal. So this is the same. You can write down a lot of things. Allow me to put it here. So it's going to be minus 4 plus 2i. That's the final answer. It's in the standard form. Your real number, imaginary number, we're all good. Okay. Awesome. Okay, 2. Right. Then let me see this one. This one is easy. So we have this one is 3 plus 5i. Remember, we're dealing with addition and subtraction, guys, so don't be surprised. Number 1. The last one is could be that minus 5 plus 7i minus negative 11 plus 2i. Guys, I hope now you can be able to, just take a moment, just pause the video, guys. Pause the video and do these 2 problems, okay? Then now, check what's going to happen. You group them. It's going to be 3. Take them, you just take them out of the house, okay? Take them out of the shelter. So 3 plus 5i plus 6. So now you're going to see 3 plus 6 all together plus 5i. And this part here will give you, what is 3 plus 6? 9. So meaning that here the answer is going to be 9 plus 5i. So real number, imaginary number. I hope you got that right. Anyhow, guys, if you there are other methods that you guys can use. So as long as it makes sense, it can take you back, guys. You're on the right track. Just don't do something that if I ask you to go back, you're gonna fail to go back, because when are you just happy because of you got the same answer as me? It doesn't. That's not how it works in math. You need to be able to. Math is like an oscillation. Math it's like a wave. You must be able to go shh, shh, shh. You get what I'm saying, guys? Okay. So let's move on with this one. This one, our method, as we always do, minus 5 will minus, negative times negative is what? Basically positive. So I'm going to say negative into negative 11. And then someone can say, okay, minus into the 7i plus. Okay, is it correct if I do the plus? Remember I showed you the method. So I can just say plus, and then here I write the what? The minus 2i. Then now check what's going to happen. Negative times negative is positive. So minus 5 plus 11 plus I 7 minus 2. Okay. All right. Let's make sure everything is correct and clear. So we're going to have minus 5 plus 11 plus I into 7 minus 2. Okay, guys. Then yeah, from here what happens, guys? You just work it out, guys. From here you just work it out, guys. You work out this. These 2 are real numbers and these 2 are imaginary numbers. Okay, so basically you can see here it's gonna be plus what? 7 minus 2, guys. So basically this is what I do with my girl. If you check us on TikTok, guys, are with my girl. So she usually says to me that don't use a calculator. No. Even when we are alive, she always be like, guys, don't use a calculator. All right. So those that are struggling, guys, she said that you guys can make use of blocks, pencils, pens, crayons, just to make sure that you use them for for counting and all of that. So you're having, let's just say having 7. 1, 2, 3, 4, 5, 6, 7. So we need to take away 2 from 7. We take away 2. So let's take away 2. How many are we left with? 5. Then I'm going to write what? 5i. Then this one, it's minus 5 plus 11. Guys, this is the same as 11 minus 5. Just to can write it nicely for you. So we are having 11. So from 11 we're taking away. So basically this is 10. Right? So it's 10 and with my nose it's 11. With my nose it's 11. Right? So let's take away 5. I take away 5. Then the 5 including my nose is what? 6. So meaning it's gonna be what? 6 plus 5i. If she was here, my girl was gonna be like, you see, that's a very good job. So but yeah guys, this is really how we decompose complex numbers. We synthesize complex numbers. I hope this video was very much helpful for you guys to can learn about what complex numbers are and how do we simplify them, how do we work them out. Okay guys, so there's gonna be more problems coming, more videos coming of complex numbers, you know, of multiplication and division and the power of the iota, the power of iota, meaning your I that equals to the square root of -1. Excuse me for that. So yeah fam, this is where I end with my session, and I'm gonna tell you guys that don't forget to pray all the time. Wherever you go, don't forget to praise God, don't forget to worship. And yeah guys, the decomposer is there, Bafetu, decomposing things. So yeah, check me out on TikTok as James the Decomposer and the Synthesizer. I'm also here on YouTube, Bafetu. Please don't forget to subscribe, like, share, comment. Bona bafethu, siyaphezulu bafethu, siyaphezulu. Angithi bafethu, siyaphezulu. By the grace of the Almighty God bafethu, let's keep on pushing bafethu. All the best. Love you all.